So today is a day in which we are learning little cheats, little easy ways to get around some things that might present a problem otherwise. Okay, so today is just a matter of how to simplify something if we don't have a calculator, if we don't know how to put it into the calculator. It's how can we figure these things out. So these are, I call like today's the cheat day, all right? So the first thing we have to know is if I'm to simplify 2 raised to the log base 2 of 8, first thing you need to realize is that a logarithm can be written as an exponent. So the exponent is log base 2 of 8. I know it looks nuts, but it's legit. We can do that. So I ask you, what is the base of the exponent? 2. The base of the exponent is this 2. What's the base of the logarithm? 2. And it goes back to what we talked about yesterday. It's all about the base. Okay? So yesterday it was kind of fun, kind of cutesy, but it really is. Okay? It really is, especially today. It's all about the base. All right? So, if the base of the exponent and the base of the logarithm are the same, here it is right here. If the base of the logarithm and the base of the exponent are the same, you get to cancel all that out. And you're only left with, in mathematical terms, it's called the argument, but you're left with just 8. So I move down. Again, the logarithm is positioned in the exponent as the exponent. What's the base of the exponent? What's the base of the logarithm?
3.
And because they're the same,
9.
I can cancel them, and I am left with
Same thing.
base of the exponent, base of the logarithm. They're both 5. They can cancel, so I'm left with 625. Moving over here. Again, don't overthink it. You're left with 16.
E4.
Now, I have e raised to the natural log of 4. Something that I want to make sure that you have, and I'd like you to write this at the top of your notes, that if I have this, and I'm going to come back to this problem down here, but if I have log 5, that is called a common log, because what's my base here? Do you see a base? Is there any base written?
Yes.
No base is written, but what is the base?
It's not
I'm like, you see a base there? I certainly don't. Okay, but it is. It's a common log with, Evan's right, with base 10. We assume the base of 10 there. That is the log on your calculator. Okay? When it's just log with no base, that's called a common log. Now, if we have ln 5, that is called a natural log. There's a common log, log, then there's a natural log, ln. ln has a base of what? Base of e. That is ln on your calculator. Okay? So that's the ln on your calculator. So there's 2 buttons on your calculator. log, that's common log. ln, that's the natural log. Common log base 10, natural log base e. All right, knowing that and refreshing that, let's go back to these problems right here. I have e raised to the natural log 4. What is the base of natural log? I just said it. E. So this and that have the same base. They can cancel. I'm left with 4. E raised to the natural log 8. Natural log has a base of e. Those cancel. I'm left with 8. Okay? Amazing. Okay, second section. What if it's not written quite so nicely for us, though? 10 raised to the natural log. That would not be a natural log. That is called a common log. That common log has a base of, so my answer is 2. Same thing as what we did above. Okay, so now I have log base 3 of, okay, well, first of all, we've got something different going on here. We've got a logarithm, and now our argument, that's what that position right there is called. That in itself is an exponent. I still have 2 bases. I have the base of the the base of the logarithm. And since that's my exponential function there, I still have a base of an exponent. It's just written differently, but I still have 2 bases. You just need to be able to recognize that. It's going to either be written like A, where the log is in the exponent, or B, where the log is written normally, but the exponent is contained within the log. Okay, 2 different ways. Work exactly the same way. If the bases are the same, they can cancel. But the problem is the base of the exponent and the base of the logarithm are not the same. So here's what I want to ask you. Can 9, the base of the exponent, be rewritten with a base of 3? 3 to the what power? So all I did is I replaced 9 with 3 squared. I replaced 9 with 3 squared, and I'm manipulating it, I'm changing it, I'm tweaking it to get this base of the logarithm to be the same as the base of the exponent. They still cancel. And what am I left with? 2x. Because an exponent being raised to an exponent is multiplication, so that's why it's just 2x, not 2 to the x power. It's just 2x. Okay, let's look at C. Base 10 raised to the log, and that's a common log of x. What's the base of that logarithm if it's not written? Those are the same. I'm just left with x. Okay. D. I have log base 5. Can 125 be rewritten to something raised to the what power? 3rd power. Because 5 cubed is 125. And if you don't know that, grab your calculator and you can do like 5 times 5 times 5, and you'll see that that is 125.
Put x as the exponent.
Because the exponent was there.
It didn't matter about, you didn't care though?
What do you mean? I do care. It's still there.
I mean, we didn't really do anything with it, did we?
No, we're not solving. We're simplifying.
Okay.
We're not solving. We're not trying to find what is x. So the 5's cancel, and I'm left with 3x. Okay? Base 10, common log, left with 5x. Because that common log has a base of 10. We just don't write it. F has a base of what? 10. but the argument is 10,000. And if you know,
Quick math.
if you count your zeros, how many zeros do I have?
4.
That's the exponent with a base of 10, always, as long as it's all zeros. And I keep the x. So the log and the base of the exponent cancel out, and I'm left with 4x. It's about the base. If the bases are the same, whether it's a logarithm or the exponents, you can cancel them out. The log gets canceled with it. Okay, so notice in all these answers that I've canceled, none of them have the word log with them or natural log. That gets canceled with it. If the base of the log and the base of the exponent are the same, you just cancel it out. It's that simple. And if you notice, if they don't cancel, if they're not the same, well, ask yourself, can I rewrite that as a base so that they are the same? And that's what we did like on D. The base of the logarithm was 5, but can I take the base of that exponent and rewrite it with the base of 5? I sure can. 5 cubed is the same thing as 125. And then I could cancel. Okay? So that's simplifying logarithms. And all of those, we completely got rid of the log by knowing that if the base of the log and the base of the exponent is the same, they just cancel out. Okay, now this, what we're going to learn down below, is called the change of base formula. Okay, and I'm going to refer to it like this, the change of base formula. Yesterday, we were given part of our homework, actually it was our notes. We had problems like this in the middle. We only did a couple of them because I said we're going to learn a much simpler way tomorrow. Well, this is the simpler way, okay, on how to do that middle part right there. And if I have log base 3 of 7, and what we learned yesterday was if we set that equal to x, because this says evaluate, which means to solve. So I want an actual answer. Well, it's written as a log, which means that I can rewrite it as an exponent. So using the snail method, I can say 3 to the x power is 7. So, you guys, 3 raised to what power gives me 7? Somebody tell me that.
What power?
Nothing.
Well, not a whole number, and if you know that off the top of your head, you need to be teaching the class, okay?
0.5.
So, the guessing and checking is really not a viable solution on this. That's why we have logarithms. This is why we are learning logarithms for this purpose right here, is to find out what is x. But my problem comes on our calculator. The LOG button on our calculator has a base of what? 10. Is this base 10? No. So I can't use this log button the way this is written. So we're going to change it. That's why it's called the change of base formula. Now, this piece comes in. Once a base, always a base. I want you to get to the place where you can finish my sandwich. Once a base, always a base. Once a base, always a base. And the reason why that's so important is because we're going to rewrite this using 2 different logs. I'm going to say log, common log 7, divided by, Ashton, put that down, common log 3. The order on that is very important. And the way you remember that, once a base, always a base. The base of the logarithm becomes the base of the denominator, or the base of the fraction, which is the denominator. So on your calculator, you're literally going to type in log 7, and be sure to close out your parenthesis on that, and then you're going to divide by log 3. And I want you all to be doing that on your calculator so that you know what kind of calculator you're using. Some calculators, we were having to do it backwards. And you're going to get about 1.77. So double check that.
This calculator doesn't have it, Miss Meyer.
It does.
The log.
Look above the PRB button then, if it's not there.
It says it's like a triangle with a D.
Then let's look at number 4. And just because I'm on video, I'm going to keep going, but I'll come back and answer questions, okay? Number 4 would be log 14 divided by log 5. And you should get approximately 1.64. Cross off the natural logs because that's not change of the base. We're not going to be doing those. Number 5, log 21 divided by log 8. Always, 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 the base of the logarithm is the same as the base of the fraction. Base of the logarithm is the same as the base of the fraction. And we're totally going out of order. Finishing with log 3, or excuse me, number 3, I get log 15 divided by log 6. And you should get approximately 1.51.